Welcome to Programming News. It's August 27, 2026. Today, we're looking at a major move in the data infrastructure space with AWS acquiring the team behind DuckDB, a new professionalized maintenance model for the Rust ecosystem, and a cautionary tale about the dangers of a single wildcard in a deployment script. We start with a significant shift in how developers might interact with analytical databases. Amazon Web Services has acquired DuckLabs, the company behind the popular open-source DuckDB database. While the financial terms of the deal haven't been made public, the strategic implications for the industry are clear. DuckDB has become a go-to tool for in-process analytical processing, or OLAP, making it incredibly efficient for developers who need to run complex queries on local data without the overhead of a massive separate database server. Naturally, an acquisition of this scale brings questions about the future of the project's open-source status. AWS has responded to those concerns by stating that DuckDB and its related projects will remain free and open source under their existing MIT licenses. The nonprofit DuckDB Foundation is also expected to continue its role in guiding the project. However, to help manage the transition and prevent any potential conflicts of interest between a major cloud provider and the community, the Foundation is currently considering the creation of a new technical advisory board. This board would act as a communication channel to ensure that the voices of individual developers and smaller stakeholders are heard alongside the larger corporate contributors. Moving from data infrastructure to language governance, the Rust ecosystem is taking a major step toward long-term stability. The Rust Foundation has officially launched its first Maintainers in Residence program. For years, the community has discussed the risks of relying on volunteer-led maintenance for such a critical piece of global software infrastructure. This new initiative is a direct response to those concerns, providing stable, professionalized financial support to the people who keep the language running. The program is backed by significant funding from the Rust Foundation Maintainers Fund, which includes donations from major players like Google, AWS, and OpenAI, as well as the Rust Project Leadership Council and individual sponsors. The first cohort consists of 6 contributors receiving at least 12 months of funding. These roles aren't all full-time. They include half-time positions and specific grants, allowing the Foundation to target the most critical, yet often underfunded, parts of the stack. Specifically, the cohort includes Jen Lai, who is working full-time on RustUp, Chris Denton, focusing on the standard library, the compiler, and Windows. Related support, Alejandro Gonzalez, working on Clippy, and Leon Lear, focusing on RustDoc and the compiler. Additionally, Jason Newcomb and Jonas Buttiger have been named as maintainer grant recipients. The selection process prioritized areas with high impact but limited resources, such as Cargo, Rust Armed, and the Rust Analyzer. While the Foundation noted that finding available maintainers for certain teams remains a challenge, the goal is to use this initial group to prove the model and eventually scale it across the entire ecosystem. Finally, we look at a story that serves as a stark reminder of why testing automation in a sandbox is a non-negotiable part of any DevOps workflow. An IT professional recently faced a catastrophic system failure after attempting to automate a routine maintenance task on a Windows NT4 Exchange server. The goal of the automation was straightforward: once a week, a batch script was supposed to stop the service, run a utility to compact the database, delete temporary files, and then restart the service. During testing, everything worked exactly as intended. But when the script ran in the live environment, a single error changed everything. The script utilized a wildcard delete command, but failed to specify a target directory. Because the command lacked a specific path, it executed within the system32 folder. Instead of cleaning up temporary files, the script began deleting essential system files, ultimately rendering the server completely unbootable. The mistake was so thorough that it required a full system rebuild and a weekend-long effort to restore the server from backups. It's a high-cost lesson in the power of automation. A single misplaced character can turn a routine maintenance task into a major outage. Whether it's a multi-million-dollar acquisition by a cloud giant or a single wildcard in a batch script, the theme of today's news is the same. The stability of our development ecosystem depends on the rigor of its governance and the precision of its automation.